Hi, and welcome to our video. Today, we will explain what is thermal expansion and how it also, we will give a problem and we will solve it step by step. Let's get right into it. So, what is thermal expansion? Well, thermal expansion is a fractional change in size of a material in response to a change in temperature. It includes change in length compared to original length called linear expansion. Changes in area compared to original area called area expansion or superficial expansion, and changes in volume compared to original volume called volumetric expansion or cubical expansion. Also, there are three main equations to solve for solids, liquids, and gases.
Hello everyone and welcome. I'm going to explain you the glossary that all the keywords you need to know to do the next problem. So let's get started. First of all, you need to know what is slope. Slope is the steepness of a linear function. What is followed is what it is the y-intercept. The y-intercept is a point when the dependent variable is equal to 0. Next, we need to know what it is temperature. Temperature is a degree of heat in an object. What is followed is volume. Volume is the amount of space that a substance or object occupies. What is after is the coefficient of thermal expansion. The coefficient of thermal expansion is a material property that indicates how much an object expands of certain temperature. Then it's the initial volume of an object, which is environmental, and temperature, which is equal to y-intercept. Then the rate of increase and decrease of an object volume, depending on the temperature, is equal to slope. And that's pretty much it. Let's go and make the problem.
The problem we will be solving in this video is the following. You need to fill a pool of 80 meters cubed, but right now you only have 40 meters cubed of water. Since you are a scientist, you know that the coefficient of thermal expansion of water is 1.5. So, at which temperature the water should be in order to get to a pool totally filled?
So for this problem, we will be using a linear function equation. So we have our dependent variable, which is the y, that is equal to the multiplication of the slope, which is the steepness of a function. We have the independent variable, which is the one that we can control. It is on the x-axis, it will be represented by x. And we have it plus b, which is our y-intercept when the independent variable is 0. So now in our thermal expansion equation, we have that S, the size or volume, is equal to the coefficient of expansion of an object. So it is how much does it changes different temperatures. We have our temperature that we can control plus B, that is our initial point when the temperature is equal to 0 Celsius. Now we can see that this problem we want to fill a pool of 80 cubic meters. So instead of the S or Y, we will put an 80. Then for the slope, which is our coefficient of expansion, we will put 1.5, which is the one of water in this problem. We want to know at which temperature, so the temperature we will leave it like that, like T. And we know that the starting point of the water at 0 Celsius will be 40 meters. So here we have our equation. Then we will do something called isolate, finding the temperature at which it will give us 80 meters. So now we want to eliminate the 40 on the side of the T. So what we will do is we're gonna subtract 40 from both sides. So now we have a 40 on the left side, and we have 1.5 T the other side, and we don't have any 40 anymore. So now we will do the same but with 1.5. As it is multiplicating, we will divide both sides by 1.5. It will be 40 between 1.5 by 1.5 and 1.5 over 1.5. And here we have our T. So now we have isolated T, 40 over 1.5, which will give us 26.66. This is our temperature for the water. So now you know linear function and thermal expansion. Thank you for watching this video.